Hi, today we're going to study the binomial distribution in 5 minutes. Well, the binomial distribution is actually a set of n recurring experiments with a chance to have a success or a failure in each and every trial. The number of possible succeeded trials would be 0, 1, 2, 3, and all the way up to n. The binomial probability has two elements. The first one would be the n, which is the number of independent trials. And the second one would be p, which is the chance of success in each and every trial independently. Right. And the probability function is looking like this, as we have already got to know probability functions. It has one row, upper row of the relevant values, and at the bottom we have the probabilities. The relevant values are the number of successes trials. So we're starting from 0 to 1 to 2 to 3 all the way up to n, just like we have done before. As for the probability to have exactly k successes altogether and n minus k failures, the probability is defined like this. We have n over k, which is the number of combinations of k successes out of totally n trials, times p to the k, which is the probability of success multiplied k times 1 minus p, which is the probability to failure to the power of n minus k, which is actually the number of failures. As for the expected values, variance and standard deviation, the expected value is defined as n times p. The variance is defined as n times p times 1 minus p, or n times p times q. And the standard deviation, as usual, is defined as the square root of the variance. Now, let's see a quick example. Say that Jack wants to shoot some hoops on Sunday afternoon. We know that Jack's chance to succeed in a single shot is p equals 0.58, means that he have 58% chance to succeed in a single shot. So if Johnny's trying 5 times, what is the chance? What's the chance that he'll have exactly 2 successful shots? Now, all we need to do is work on the very same formula we've just shown, which is 5 over 2 times 0.58 squared times minus 1 minus 0.58 to the power of 3. And altogether, it is 0.2492, which means 24.92% out of 5 shots, he'll succeed in exactly 2 shots. Now, if Jack is trying 7 times, what is the expected number of successes he'll have? What's the variance, and what's the standard deviation of those number of success? Now, as for the expected number of successes, we've just covered that n times p, which is 4 times 4.06. The variance would be n times p times 1 minus p, which is 7 times 0.58 times 0.42, which is 1 times 7052. And the standard deviation would be the square root of the variance, which is 1.3058. Now, as for 4 trials, let's show the Jack's probability function. So we can see that we have 4 trials. Jack can succeed all the way from 0 to 4. And we are using the same formula to fit the probabilities per possible number of successes. Now, we need to make sure this is indeed a probability function, which is exactly what we find since all of the probabilities adds up to 1 on the one hand, and all probabilities are positive and satisfy this. They are higher or equal to 0 and lower or equal to 1. Thank you for listening. Hope you have studied for that, and see you in the next lesson.